For our second lesson, we are going to continue with equations of circles, but this time we're going to look at equations that are not what we consider to be in standard form. And what I mean by standard form is what we looked at the other day, where it was x minus h squared plus y minus k squared equals r squared. That's what we consider to be standard form. So today we'll look at ones that are not in that form, and we have to get them to be in that form. And the way to do that is actually by using a skill that you learned last year in Algebra 1, which was completing the square. So I thought it would be a good idea to do these two do now questions. This is what you did last year, completing the square. So solving by completing the square. So if you remember, last year what you would have done to solve this, we want to solve for the roots, and we want to do this by completing the square. What we're going to first do is make sure our leading coefficient is a 1. It is. Next thing we're going to do is move over our constant. So we're looking at x squared plus 4x equals 16. Okay, I'm going to write another line here. I'm going to leave a little bit of a space. So I'm going to put a box. Now, if you remember last year with completing the square, we're trying to make this to be what we call a perfect square trinomial, meaning that it factors to be the same thing twice. So the way to do that is by taking our b value. So just kind of a quick thing here, ax squared plus bx plus c. We're going to take our b value, which in this case is 4. We're going to take our b value, half it. So our b value is 4. We're going to take our b value, half it, and square it. So that b value is 4. Divide it by 2, so half it, and then square it. So 4 divided by 2 is 2, and 2 squared is 4. So we're going to add that to both sides. And the reason why we're doing that, and we're going to do it to both sides, so what we do on one side, we do to the other to keep it balanced. But the reason why we're doing that is because now this is factorable. This is factorable to be x plus 2 times x plus 2. Or in other words, x plus 2 squared. So this factors to be x plus 2 squared equals 20. So now at this point, we're going to go ahead and solve this out. So we'll square root both sides to get rid of the square. If you square root both sides, don't forget it's plus or minus. Then move the 2 over. And then we could break down that square root of 20 to be 2 radical 5. So that's one way to solve. Remember, we have a couple of ways to solve. We try to factor at first. If not, we look to use the quadratic formula or what we call completing the square, which is what we just did. Now, that's not what we're going to do today. We're not going to solve quadratics, but we are going to use the skill of completing the square. So I think it's probably a good idea to do one more. We want to make sure our leading coefficient is a 1. It is. We want to move our constant over. It actually already is moved over. Now at this point, we have to figure out what number do we have to add to both sides to make it what we call that perfect square trinomial. And the way we figure that out is by taking our b value, which is -8. So take -8, half it, and then square it. So -4 squared is 16. So 16 is that special number that we're adding to both sides. This now is factorable. So we think what multiplies to 16 adds to -8. What multiplies to 16 adds to -8. It's going to be -4 and -4, or x minus 4 squared. I don't know if you realize, but it's always going to be whatever half of that b value is. Half of -8 is -4. Half of 4 is 2. It will always be that way. And then we'll go ahead and add 24 and 16, so 40. Okay, we'll solve this out. X minus 4 equals plus or minus square root of 40. And then move the 4 over. And we'll break down that radical 40 to be 2 radical 10. So square root of 40, square root of 4, square root of 10, that becomes 2 radical 10. And then that is our answer solved out. Again, we're not going to be solving quadratics, but we are going to use this skill. Okay, so here's how we're going to use this. Now, like I mentioned in the beginning, equations of circles are not always in that nice x minus h squared plus y minus k squared equals r squared, and it's going to be difficult to identify the center and the radius. But if we can use that completing the square process skill, then it allows us to put it in that form. So if I take a look at this, this is actually an equation of a circle. The reason why I know it's an equation of a circle, and you need to be able to identify an equation of a circle, but I know it's an equation of a circle because there's an x squared and a y squared. If x and y are both squared, then in this course it's going to be a circle. So because it's not in that nice x minus h squared plus y minus k squared form, we need to go ahead and get it in that form. And that's where completing the square is going to come into play. So I'll move this down here. And here's how we're going to do that. So the first thing we want to do is make sure our leading coefficient of our x squared is a 1. And it is, just like our process with completing the square. So the first thing we want to make sure is that the leading coefficient in front of our x squared is a 1, just like our process with completing the square. And in this case, it already is. Then the next thing we really want to try to do is group together our x's, which they already are, and group together our y's, which they already are, and move the constant over to the other side, which it already is. Now we're basically going to treat this as 2 completing the squares. We have x squared minus 4x, and we're going to want to add something, then plus y squared minus 8y, and again we're going to want to add something, equals 5 plus the number we add to the x's plus the number we add to the y's. So we're really basically doing 2 completing the squares. We're doing a completing the square process for our x's, and we're doing a completing the square process for our y's. So we want to ask ourselves, what is that number that we need to add over here to make it that perfect square trinomial? So we're going to take our b value, half it, and then square it. So negative 4 divided by 2 is negative 2, and then negative 2 times negative 2 is 4. So we're going to add 4 over here, and when we add to one side, we have to add to the other, so we're going to add 4 over here. Now we do the same process for our y's. So this time we're going to take negative 8, that's our b value, divide it by 2, and then square it. So that's going to be negative 4, and negative 4 times negative 4 is 16. So we're adding 16 over here and 16 over here. One of the common mistakes is not adding it to both sides. We want to make sure we do that. Now this we're going to look to factor. So it's going to be a perfect square trinomial, so it's the same factor twice. The trick is always taking half of your b value. So it's just going to be x minus 2. Let me do it back in the blue color. So it's going to be x minus 2 times x minus 2, or x minus 2 squared. Okay. Then plus, now we do factor this. Again, it's going to be that perfect square trinomial. What multiplies to 16 adds to negative 8? Well, that's negative 4 and negative 4, or y minus 4 squared. And again, the trick is it's always half of this. And then we'll add up these numbers. 5, 4, and 16 is 25. Now this looks much nicer. We could see that the center is 2, 4, and the radius is 5. The center is 2, 4, and the radius is 5. It's in that nice form where we could really pull everything out. And the last thing was to graph the circle. So we didn't do graphing yesterday, but it's really pretty intuitive here. We're going to graph our center, which is 2, 4. So here's 2, 4. And the radius is 5, which means every point on the circle, so on this circle we draw, every point on this circle has to have a radius of 5. So I'm going to plot 4 points. I'm going to go 5 to the right, 1, 2, 3, 4, 5. 5 up, 1, 2, 3, 4, 5. 5 to the left, 1, 2, 3, 4, 5. And 5 down, 1, 2, 3, 4, 5. And if you have a compass, definitely go ahead and use that. I have this circle tool here. So that's going to make it nice and easy here to make it circular. If you're just drawing freehand, that's fine too. And there's our equation of our circle. There's our equation, there's our graph of our circle, I should say. Okay. So there's just a couple of practice here. I'll do them with you since this is a new skill. Okay, the first thing we're going to do is make sure our leading coefficient for in front of the x is a 1. It is. Then we'll group our x's together and our y's together. They already are. And we want to move our constant over. It already is. So at this point, we could go ahead and start thinking about how we're going to be completing the square for both of these. So again, I'm adding it to both sides. All right, so we're looking for completing the square for this and completing the square for this. So I'm going to take my b value, which is 8, take 8, half it, take 8, half it, and then square it. So that's going to be 16. Take -4, half it, and then square it for the y's, and that's going to be 4. Okay, now we can go ahead and factor this. So this is going to factor to be what multiplies to 16, adds to 8. That's x plus 4 squared. Again, the easiest thing is just taking half of that b value. What multiplies to 4 adds to -4. Again, the easiest thing is just taking half of that b value, so -2. And then we're going to have to add this. 16 and 16 is 32, plus 4 is a 36. And then it says write it in standard form. It's now in standard form. Let's identify the center, which is -4, 2. And let's identify the radius, which is 6. Remember, this is r squared. This here is r squared. So the square root of that would be 6. Okay, we'll take a look at our next one here. Let me just minimize this to get more room. Okay, so looking at our next one, we want to make sure the leading coefficient is 1. It is. Group the x's together, group the y's together. It already is. Move the constant over. It actually already is. So everything's really set up nicely for us. So we have x squared minus 18x plus some number plus y squared minus 10y plus some number equals -6 plus those numbers that we add. So we're going to start completing the square. We're going to do that process. We're going to take half of -18, which is -9, square -9, and that's 81. Okay, so we're adding 81 to both sides. Then for here, take half of -10, divide it by 2, which is -5, and square it. That's 25. So we're adding 25 to both sides over here. Okay, so we're going to factor this. They'll be perfect square trinomials. What multiplies to 81 adds to negative 18. That's going to be negative 9 and negative 9. Again, easiest thing is it's just half of that. Then what multiplies to 25 adds to negative 10. Y minus 5 and y minus 5. Again, just half of that. And that's going to equal, is that going to be 100? It's going to equal 100. So our center is 9, 5, and the radius is 10. So we'll take a look at C here. So C is a little bit different in the fact that the leading coefficient is not a 1. So to take care of that, we're going to divide both sides by 2. So we're looking at x squared plus 2x plus y squared minus 2y equals 7. So we divided everything by 2. And now we're going to go ahead and do our completing the square. So we have to think, what number do we have to add over here? What number do we have to add over here to make it those perfect square trinomials? So it's going to be x squared plus 2x plus 1 plus y squared minus 2y plus 1 equals 7 plus 1 plus 1. If we added the 1's over there, we have to add it over on the right side as well. Now this factors to be x plus 1 squared. This factors to be y minus 1 squared. And that's going to equal 9. So now our center is negative 1, 1, and the radius is 3. We'll take a look at 2 Regents questions. So this was a multiple choice. They have Kevin's work for deriving the equation of a circle is shown below. In which step did he make an error? So we just have to follow what he did through. So it looks like in his first step he distributed the negative 1. That looks good, so step 1 looks fine. In step 2 it looks like he started completing the square. So he decided, okay, I have to take half of this, divide it by 2, and square it. So he realized he needs to be adding 4. He added 4 over here, but then he subtracted 4 over here. That's a problem. He's not keeping his equation balanced. So I don't even need to go any further. Step 2 is where he made his mistake. That's where he made his error. He should have added, this should have been plus 4. He should have added 4 to both sides. Okay, and the last one. Why don't you pause the video and try this one on your own, and then I'll show you the answer after you're done. Okay, so pause it and try. So doing this work out, this one was actually kind of nice because you didn't have to do as much work because there's nothing to do there. It's just x squared, so you're kind of done there. The center is going to be 0 comma something because there's nothing there for that. But then we did have to complete the square over here for the y's. So taking half of negative 6 and squaring it is 9. Add that to both sides. So now this here is going to factor to give us y minus 3 squared. I add negative 1 and 9 to give us 8. So the center, again, nothing going on here for these x's, so it must be x minus 0 squared. So 0 is your x value for your center, and 3 is your y value for your center for the y's. And then the radius, well, that's going to be square root of 8. Only one choice really works out. You don't even have to break that down if you don't want to, because it's going to wind up being choice 1. Okay, so you don't have any homework to do. Just submit these notes, and then that's fine. If you want to do these extra practice questions, feel free. You definitely do not have to. Okay, have a good one. Bye.